Hi friends, welcome to the new video. Today I am introducing a 50 MHz frequency counter. It is from the Google. Search the Ham Radio India. We can see this site. Search the multifunction low cost VFO. All the details are given in it. Then scroll down. You can read all the details in these articles. PCB layout, circuit diagrams, all are given in it. The assembly files and the hex codes are downloaded from the bottom side of the articles. I have already downloaded and keep it in my computer. You can also do it. If it is not available, I will give you in my email address. See, this is the circuit diagram. The main parts are shown in here. The 168 F628 microcontroller and 16:1 display. Some buttons are also given here for BFO. This is the schematic of the PCB. You can download it and make it by the toner transfer method. This is the circuit diagram. It can be downloaded from the download button, which is given at the bottom of the circuit, and we can enlarge it. This is the complete circuit diagram, and we can enlarge it. By enlarging, you can see this is the microcontroller 16F628. The circuit connection is very simple. You can make it on a multi-purpose PCB also. See, this is the microcontroller. It is the heart of the circuit. This microcontroller have to be programmed before we can use. The programming sequence are explaining later. And this is the circuit connections, and the input frequency is given by this amplifier. 2 microhenry coils are given. It is very essential for the circuit. 10 microhenry minimum required, and 2 1N4148 diodes are given in the input of the transistor. It is very essential because we are not able to measure the very high amplitude of the signal. And this is the 16:1 display. On this circuit, we have to use 16:1 display only, otherwise it may give error. This is a homebrewed PIC2 programmer. Now inserting in it, and we can program this microcontroller with the PIC2 programmer. We can open it. This is the PIC2 programmer. The hex file is already downloaded in my computer. We can load it. See the process. The PIC2 window is open now, and we can import the hex file. The hex file is loaded here, and we can search, and the hex file is loading. This is the hex file. Open it. See, and upload it. The programming is completed and the program successful. and then we can remove the PQ2 programmer and remove the IC. Then this is the circuit which I have made in a multi-purpose board. It is very simple because it is using digital signals. We can use this multi-purpose board. It will not give any error. It will give very accurate frequency output. The crystal used is 4 MHz crystal. There is a small trimmer. That trimmer is using for the frequency correction. Now the IC is inserted properly. Noting the pin connection. This is a 16:1 display, and now I am inserting the display in the socket. Now we can power up with the 12 volt because 5 volt regulator is connected in it. Now see, that program is good. It will show FC frequency counter, and the version is also seen it, and the frequency is the measuring display. This is the default display. See, this is the default display. This is a multi-purpose multi-function frequency counter. This is the clean view of the display, and now we can measure the output. This is a DDS VFO. This DDS VFO. Now we can connect the frequency counter to check the output of the DDS VFO. The DDS VFO we are measuring. The DDS VFO showing 7 MHz. That means the output will be 3 MHz. Okay. Now our frequency counter is okay. It is showing 3 MHz output. The D at the last indicates the direct measuring. By rotating the encoder, the display frequency is changing. While we increasing the DDS VFO output from 7 MHz to 7.05, 7.06. In that way, the frequency in our frequency counter will reduce. It will give 1.9500 MHz when we are keeping the DDS at 7.050, and it is 7.1. Then the output of the DDS is 2.9 MHz. This is using for the Bitex 40 MHz 40 meter Bitex radio. Thank you for watching. Please comment and subscribe.